Hey everybody, we're going to talk about table of outcomes and compound events. If you notice, there is a table at the top that's talking about exiting a ride at a theme park and saying if you liked it or disliked it. For time's sake, I already totaled everything for us just so you can see some of the problems that we do. And on the bottom, we're going to talk about estimating the probability of these events. So, first one, probability that you liked the ride. That is the 83 out of the 130. And that is all. All right, what is the probability that the person was a child and disliked the ride? So child and disliking is the 17 from the table there out of the 130 total. And that is all for that one. All right, this next one is an adult or dislike the ride. Keyword is or, so it could be the probability of being adult, which is 58. The disliking the ride, which is 47. Now, what is the downfall of this? Well, we double counted 30. We double counted the adults that disliked the ride. So we actually need to take away that 30 from our grouping, and that is 75 out of the 130, which actually then reduces to 15 out of 26. And there we have it. All right, what is the probability that they liked the ride given that he or she is a child? Well, how many total children are there? There are 72. Of those 72 kids, how many liked it? Well, that's 55. And that is all. All right, last one here. Is an adult given that he or she disliked the ride? So you go immediately to the amount of people that disliked the ride, which is 47. Of those 47 people, how many were adults? That is 30. And you are done there. All right, let's go to the back if you printed them. On the back, we're going to talk about compound events. Independent and dependent. Independent works on its own. Dependent, something happens and then the other thing takes place due to how the first thing happens. All right, so we have a coin and a dice. They are tossed simultaneously. What is the probability of getting a head and a 3? All right, so the probability of getting a head times the probability of getting a 3 is 1/2 of the head. Probability of getting a 3 is a 1 out of 6, so your answer is 1 out of 12. All right, next one. A box contains 4 red and 2 yellow tickets. 2 tickets are randomly selected from the box, one by one, without replacement. That's a key thing. Find the probability that both are red. Well, you have 4 of the 6. Oops, wrong thing. 4 of the 6 are red. And then the probability that the next one is red, well, there's only 3 left now of the 5 because we did not replace it. That is 12 out of the 30, which then reduces to 2 out of 5. Alrighty, next one. The first one is red, and the second one is yellow. So we know the first one being red is 4 out of 6. The second one being yellow, there's still 2 yellow, but there's only 5 total out of that. So that would be 8 of your 30, which reduces to 4 out of 15. All right, last thing here. A hat contains 20 tickets. They're numbered 1 through 20. 3 are drawn from the hat without replacement, key thing. Determine the probability that they're all prime numbers. So in case you forgot what a prime number is, it's a natural number greater than 1 that has no positive divisors other than 1 in itself. So let's start listing off the prime numbers. 2, 3, 5, 7, 11, 13, 17, and 19. There are 1, 2, 3, 4, 5, 6, 7, 8 of those. So let's go back to the thing. There's 8 numbers here. It says 3 are drawn. Determine the probability that they are prime. All right, so 8 out of 20. We are not replacing anything. 7 out of 19. Not replacing anything, 6 out of 18. And if you do the quick math on that and let it reduce it for you, that is 14 out of 285. If you can write it as a fraction, it'll probably be easier to leave it as a fraction. But other than that, we are good for this. All right, guys, have fun. See ya.